In a given population, one can find out the frequency of occurrence of alleles of a gene or a locus. This frequency is supposed to remain fixed and even remain the same through generations. Hardy-Weinberg principle stated it using algebraic equations. This principle says that allele frequencies in a population are stable and is constant from generation to generation. The gene pool, total genes and their alleles in a population, remains a constant. This is called genetic equilibrium. Sum total of all the allelic frequencies is 1. There is two forms of an allele, one is dominant and other is recessive. Think of population of 10 individual in a classroom confined area, no evolutionary changes at biology period. If out of 10 individual with 20 alleles for height represented by A or A. If out of 20 alleles 12 alleles were of A, then its frequency represented by P becomes 12/20 equals 0.6. So the other remaining alleles has to be 8 that 2 of allele and its frequency represented by Q has to be 8/20 equals 0.4. So you see the frequency becomes 0.6 plus 0.4 equals 1. That is P plus Q equals 1. Individual frequencies, for example, can be named P, Q, etc. If in a diploid, P and Q represent the frequency of allele A and allele A. Now we need 3 variables, not 2, because genotype are not 2 types but 3 types A, and A. So 3 variables come when we square both sides of the equation. P plus Q whole square equals 1 whole square. The 3 variable is P square plus Q square plus 2PQ. The frequency of AA individuals in a population is simply P square. This is simply stated in another ways, i.e., the probability that an allele with a frequency of P appear on both the chromosomes of a diploid individual is simply the product of the probabilities, i.e., P square. Similarly, of A is Q square, of A is 2PQ. Hence, P2 plus 2PQ plus Q2 equals 1. This is a binomial expansion of P plus Q2. When frequency measured differs from expected values, the difference direction indicates the extent of evolutionary change. Disturbance in genetic equilibrium, or Hardy-Weinberg equilibrium, i.e., change of frequency of alleles in a population, would then be interpreted as resulting in evolution.